Okay, welcome back to our next lesson in complex numbers, video number 4. Today we're going to look at basic operations involving complex numbers in rectangular form. I mentioned at the end of the last video that the rules you're going to see here for adding or subtracting, for multiplying, and for dividing these complex numbers is very similar to the rules that you saw in Math 1700 for basic operations with radicals. And that shouldn't be surprising, as I said, because really imaginary numbers are just radicals. Remember that j is defined as the square root of -1, and that's a radical. Strange radical, but it's a radical. So the four rules we're going to look at are adding and subtracting, which are very straightforward, very simple. Multiplication is also fairly straightforward. You have to simplify your result usually, though. And then we're going to look at the rule for division of complex numbers in these forms. So let's look at example number 4, and this is on page 7 at the very top. It says, perform the indicated operation and write in rectangular form. Write your result. Well, if you're adding two numbers, two complex numbers, as part A tells us to do, all you really need to do is remove your brackets, and they just disappear. There's no terms in front to multiply through by. Signs are both positive. So basically, the brackets will just vanish. You're going to be left with 6 minus 5j plus, and then we have 2 plus 3j. Now, just the same as if you were adding monomials together, you can combine your like terms. So for the result here, the real numbers 6 plus 2, you would add those together to get 8. And negative 5j plus 3j combines to give you minus 2j. You cannot combine those two terms. One is real, one is imaginary. So notice that you started out with two complex numbers in rectangular form. You ended up with an answer. That's a complex number in rectangular form. B is also relatively straightforward. This one is a subtraction. What you have to be careful of for a subtraction, exactly the same as if this was two binomials, is this minus in between. Think of that as a -1 in front, and you use your distributive property to distribute the negative sign, the -1, through the second set of brackets. So removing your brackets first would leave you with 11 plus 2j. The first brackets just vanish. But for the second expression, you're going to have minus 7, and then negative multiplied by negative j becomes plus j. So it's important to watch your signs there. But once you've done that, then it's just as simple as the addition. Combine your real parts, 11 subtract 7, used to be 4, I think it still is, and plus 2j plus j is plus 3j. So there's your result right there. Okay. Part C, we have to do a multiplication. Well, remember now that you can treat this exactly the same as if you were multiplying two binomials together. It's not just two multiplications, but in fact there are 4. So we do the 4 multiplications here. 5 times 3, 5 times negative 2j, and then you would multiply negative 4j times 3 and negative 4j times negative 2j. So here's what you're going to get when you do those 4 multiplications. 5 times 3, 15. 5 times negative 2j is negative 10j. Negative 4j multiplied by 3 gives us negative 12j. Notice that those two terms you're going to be able to combine because they're like terms. That will just become minus 22j. The last multiplication you're going to do is a negative multiplied by a negative, so that's a positive something. And 4j times 2j is 8j squared. Now, if this was just two regular binomials involving x's, of course, you'd leave the x squared, the 8x squared, as it is. Not so for imaginary numbers. These two, yes, you can combine, but the j squared, remember, you have to replace that with something that's equal to j squared, which we saw a few lessons back is actually -1. So this will become 15 minus 22j, and then plus 8 times negative 1 actually becomes minus 8. Your final result is going to be 15 subtract 8, which is 7 minus 22j. And there is your result for C. So be very careful when you're multiplying. Remember that you do your 4 multiplications, yes. J squared must become negative 1, and you combine the like terms. And that's what you will have there. The last example we have here on basic operations involves a division. And this is part D, right there. And you can see that what you have is 3 plus j in the numerator divided by 2 subtract 7j in the denominator. Now, if this was radicals, you would, of course, multiply the top and the bottom by the conjugate of the denominator. Well, remember, imaginaries are radicals. So what we do is we multiply here top and bottom by 2 plus 7j. That's the conjugate of the denominator divided by 2 plus 7j. Now, if this was a quiz or if this was a test, it is extremely, extremely important to show your workings for these, because that would prove that you know exactly what you're supposed to do involving these calculations. Now, what I'm going to do is I'm just going to erase the previous calculation to give myself a little bit of space, because it's going to take a little bit of space here to actually work this one out. Wow, this eraser is not working very well. Okay, so now notice what you have to do. You have to do 4 multiplications on the top, and you also have to do 4 multiplications on the bottom. But something nice happens with the bottom, because remember, you're multiplying conjugates. And you may recall from Math 1700 that when you multiply conjugates together, the 2 middle terms will cancel each other out. So let's go ahead and multiply here. I'll give myself some space. I have 3 multiplied by 2, which is 6. I have 3 multiplied by 7j, which is plus 21j. Then I have j multiplied by 2, so that's plus 2j. And then I have j multiplied by 7j, so that's plus 7j squared. Now that's just the numerator, remember. That's just the top. Now you have the denominator. Now I'll actually do the 4 multiplications here to show you what I mean that the middle terms will cancel. But the astute student, someone who's really on the ball, knows what they're doing, you should realize the middle terms are going to cancel anyway. And then it's permissible to just multiply the 2 multiplications. 2 times 2, negative 7j times positive 7j. But I'll do all 4 here for now. All right, so I have 2 multiplied by 2 is 4. Then I have 2 multiplied by 7j. Well, that's plus 14j. But then I have negative 7j times 2, and there's minus 14j. And just as I said, they're going to cancel. And then negative 7j times positive 7j is minus 49j squared. Now remember, you have to simplify those j squareds. Another common error I've seen students do before, and this is completely wrong. Some students would look at these 2j squared terms there and think they cancel out, but they do not. They are not factors of the numerator and denominator respectively. You cannot just cancel those out. All right. In fact, you have to simplify them. So what will we get in our next step? Well, I have 6 plus 2j plus 21j, and then plus 7j squared. Remember, this j squared is negative 1. The same thing with the j squared on the bottom. That's also negative 1. So what you're really going to be left with is 6 plus 23j and plus 7 times negative 1 is minus 7. On the bottom, you're going to have 4. Middle terms cancel. Minus 49 times minus 1 becomes plus 49. Notice there is no j term left on the bottom. The denominator is now just a real number, which is what we want. So now this becomes 6 take away 7, that's negative 1 plus 23j divided by 4 plus 49, 53. Now, you can leave your answer like this if you want. Be aware that sometimes the result may simplify. You have three terms, the -1, you have 23j, and you have 53 on the bottom. If those three terms shared a common factor greater than 1, you could divide all three terms, but it has to be all three, by that common factor. Now, like I said, you can leave the answer looking just like that, which is fine. But if you wanted it to look like a complex number in rectangular form, then remember there is actually two pieces to that, isn't there? So another way that you could write it looking like it's in complex form would be -1 over 53. There's your real part. And then plus 23 over 53j. There's your imaginary part. So whichever way you write it would be fine. I'd certainly mark this correct on a test. But this clearly shows this form right here, your result in rectangular form. Check both fractions to make sure they cannot reduce. Okay. You can check these with your calculators, by the way. If you have a calculator that can actually work in complex mode, you can just type these into your calculator as a check to see if you're doing these correctly. But remember, on a test or on a quiz, I would expect to see all the workings there. If you want marks, you show your workings. Okay? So anyway, down below that now, again, this is still on page 7. There's some practice ones that you can try. The first one is an addition. The second one is a subtraction. And then we have another subtraction for C. D, you'd actually have to use your distributive property. That's a multiplication. Make sure don't end up with j squared in an expression. E and F are both multiplications. In fact, F, you're multiplying conjugates together. So what's going to happen for F? You're going to end up with only a real number as your answer. G and H are divisions. So again, I'll leave those for you to try. Make sure you check the answers in D2L to see if you're doing these correctly. And if not, make sure you pop me off an email and I'll get back to you on that. Okay, so that's the end of this video. And I'll start the next video in just a moment. Bye-bye for now.